Algebra 2, Year 2. This is 7.1, Day 2 homework. We are graphing exponential functions. Number 1 says y is equal to 3 to the x power. If you plug in these x values into this function, so if you did 3 to the negative third power, this is 1 over 27. 3 to the negative 2 power is 1/9. 3 to the negative 1 power is 1/3. Anything to the 0 power is 1. 3 to the first is 3. 3 to the second is 9. 3 to the third is 27. So if you plotted these points, what should this look like? What's the base? 3. This should be an exponential growth. So 3 to the left and up 1/27, which is close to 0. Then 1/9, 1/3, 1, 3, and 9 is the furthest you're going to be able to go. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3/27 is too big. This is a smooth curve. Now this one. Can you tell me what the y-intercept is going to be? What is it? It's going to be 2. That's your y-intercept. Now, if you were to type this in your calculator, so it's 2, and then parenthesis, or you can do fraction, 1/5. So this is going to be an exponential decay problem. Now, were we right? Is our y-intercept 2? It sure is. Now, if you don't have a calculator, you can do this by hand. Or what you can do is just use your calculator and type these in. So at negative 3, it's 250. At negative 2, it's 50. At negative 1, it's 10. 0, it's 2. All I'm doing is reading these off the table. We have 1.4. We have 2.08. We have 3.016. So if you were to graph this, obviously these two are off. We don't have enough unless we change our y values. We're not going to do that. We're just going to graph negative 110, 2, 3, 4, 5, 6, 7, 8, 9, there's 110, negative 110, 0, 2, and then 1.4. And what's happening is this is getting smaller and smaller. So I want you to realize, this is just review, this base, if the base is less than 1 and greater than 0, it's an exponential decay problem. If the base is greater than 1, it's an exponential growth. All right, now we're going to look at our table of values. What we have to do is analyze these x's and y's and determine if it's linear, quadratic, or exponential. So, can you tell me how the x value, it's going up by what? 4. How about this? This one is, can you think of a number to multiply to get 14? What is it? 7 times 2? No, I mean from here to here. How about adding and subtracting? How do you get from 25 to 14? What is it? You mean subtract 11?
Well, from 14 to 15, yeah.
From here to here, you're subtracting 11.
Right.
Is this the same if we subtracted 11? Do you get 3?
Yeah.
How about 3 minus 11? Do you get negative 8?
Yeah.
So if this is going up by 4, and this is going down by 11, this would be linear. The next one. 1 to 2, 2 to 3, 3 to 4. This is going up by 1, right? How about this, from 6 to 18? This is going up by how many? 12, but this one's not going up by 12. Can you think of a number to multiply to get from 6 to 18? 6 times what is 18? 3. What's 18 times 3? Is that 54? And is 54 times 3 162? Yes. So, if the x values are going up by something and the y values are being multiplied by something, what did we say this was? This is exponential. Exponential, I'm just gonna abbreviate. Okay, the next one. This one's going up by 2's, right? Okay, this one, I don't see a common pattern by multiplying. I don't even know, let's see, how do you go from 75 to 43? This one's going down by 32. This one's going down by 23. And this one's going down by 14. I don't see any pattern yet. But from here to here, what's that doing? It's going up by 9. And this is also going up by 9. So this has a common second set of differences, so this one's quadratic. This has a common second set of differences, that's quadratic. And the last one, this x side is going up by 3, but what's it doing from 160 to 80? It's being multiplied by a half. And this is also being multiplied by a half. And this is being multiplied by a half. So what's this? If the x value is going up or down by a certain number, and the y is being multiplied or divided, this is exponential. Good job. Exponential. Now, let's look at our equations. Which one is linear? Which one, what does linear look like? And by the way, g of x is just another name for y. Which one's linear?
4.
Number 4 is linear. He is correct. How can you rewrite 44 minus x times x?
That'd be
And that would be quadratic. Good job. How about 6? Where's the x value? It's exponential. And what about 7? Where's the x value? This would also be exponential.
So would it all be exponential if it's an exponent?
If the x value is the exponent, yes. Okay, and these ones right here. If I give you the final amount for $5,000 invested for 25 years at 10% annual interest, compounded semi-annually, is $57,000. What is the effect of doubling the amount? So if I take $5,000 and I double it, if I double this amount, so how much am I gonna invest if I double 5,000? How do you double 5,000? If I double 5,000, what do I get? So instead of investing 5,000, I'm gonna invest 10,000, double it. For 25 years at 10%, compounding semi-annually. So this would be 1 plus interest rate is 10%, 0.10. Semi-annually, n is 2. And I'm gonna do this for 25 years. Tell me how much you get. $114,674. So if you take $10,000, well, actually, if you take 5,000 and if you doubled it, that's how much money. Now, if you took $5,000 and invested it for 25 years, you'd end up with $57,337. What about doubling the interest rate? How do you double, what is the interest rate? So in other words, we're gonna keep the $5,000 as it is, but we're gonna double the R value. How do you double 10%? It'd be 20%. Still, semi-annual, so that's 2 times a year for 25 years. Tell me how much, if we doubled the interest rate and not the money, how much would you have? You wouldn't have this amount. If you doubled the interest rate, you'd end up with $954. That's like almost, that's like more than 10 times the amount. What about doubling the investment period? So instead of 25 years, it's, how do you double 25 years? You have 50 years. So keep it at 10%, semi-annually, and we're gonna double the number of years, so 50 years. How much money are you gonna end up having? So you end up with $657,506. So if I asked you this question, would you rather double? Which one has the biggest effect on the amount of money you're gonna earn? By doubling the money?
Can you move the paper, please?
Move it, which way?
No.
Like that? Okay. So in A, well, first what we did, we took $5,000. We took $5,000 and we invested it for 25 years. If we took $5,000 at 10% for 25 years, and we invested it semi-annually, so for 2 times a year, get interest, you end up with $57,337. Now, what formula do you use? A equals P times 1 plus R over N to the N times T power. So if we start off with $5,000, invest it for 25 years at 10%, compounding interest twice a year, you end up with $57,000. In other words, you're gonna earn $7,000 in interest. Well, if we double our money, you end up with $114,000. If we double our interest rate, so 10 to 20%, we end up with $586,000. And if we double our time, we end up with $657,000. So which has the biggest effect?
B.
B? Anyone have a different answer?
No, never mind.
Which is gonna change your amount the most?
C.
This is the largest amount. So by changing the number of years, by changing the exponent, that's what's gonna yield your largest amount. So by doubling the investment period, that's gonna give you the most. Now what if, one more thing. What if I asked you to do compound interest continuously? What formula do you use? See if you remember it. Compounding continuous. P, E, raised to the RT. Okay, we're done.